It all started with small changes on our planet. At first, people saw the moon brighter and a little bigger, but no one paid any attention to it. The moon affected the tides around the world. Beaches were flooded, but it was not a disaster. Lots of fish swam ashore. People discovered giant squid, fish, and other creatures living in the dark depths of the coast. Strange things happen every day. Birds don't fly south in the winter. They gather in large groups and wander aimlessly through the cities. The moon used to help them navigate nature, but now they can't figure out which way to fly. In the vast waters of the world's oceans, ship captains find that compasses are becoming increasingly unreliable. The arrow points in different directions because the Earth's magnetic poles have changed. People realize that the moon is beginning to move closer to Earth for unknown reasons. The weight of the moon affects the weight of our planet. This causes changes in climate, the behavior of all living things, and the magnetic field. It is now raining in the driest places and hot in the coldest places. It is destroying the ecosystems on the planet. People who live near the forest always hear wolf howls. The moon is driving these animals crazy. The Earth's natural satellite increases in size and lights up the night brighter. Nothing critical has happened. People don't panic because they don't want to believe the end is coming. But one day, the moon reaches a critical point. You're walking down the street, listening to music, and that's when someone pushes you. Well, maybe this guy is late for work. You keep walking, and a girl passing by strokes your shoulder. "I'm sorry," he says, and walks away. There was fear in his eyes. You look ahead and see people running towards you. Pulling out your headphones, you hear the roar of sirens. People have abandoned their cars and are scattering. There are hundreds of seabirds flying in the sky. In the midst of this chaos, you hear a strange noise. It's like water. How is that possible? You are in the heart of the city, a few miles from the coast, but there is no time to think. You see a huge wave flooding the streets and heading straight for you. You run up the building and climb to the 10th floor. From here, you can see the flooded city, the strong current washing away all the cars, one-story buildings and trees. You see sharks and other fish in the water. People are hiding in houses and on rooftops. The whole city has gone crazy. The building you are hiding in has a television. You learn that floods happen all over the world. Large tsunamis have hit poor towns. In some places, the waves are as high as a 30-story building. Many cities have been leveled to the ground. The moon is very close to the Earth, just the beginning of the flood. The moon revolves around the Earth and helps our home stay on its axis. This keeps the climate stable and allows living organisms to thrive. But now this balance has been disrupted. The moon is approaching and changing the gravity of our planet. The Earth is tilting slightly and causing floods around the world. Imagine holding a round glass of water in your hand. Hold it for a moment. See how the liquid flows from one side to the other? The same thing is happening right now with the oceans. But the moon is not the only one coming towards us. It flies around the planet and gets closer with each circle. It always causes natural disasters in different parts of the world. The ocean overflows one way, and a few hours later, it overflows the other. And then you see the water leaving the street. The ocean can come back into the city at the end of the day. 1 minute. It seems to be the end of days. You see the sky getting darker. It's strange, because it's only 3 o'clock in the afternoon. The moon changes the speed of the Earth's rotation and makes the day go faster. The moon covers almost the whole sky and lights up our planet. You can see the big lunar craters. They are so close that you can see them even when the sun is shining. In some places, The moon outshines the sun. Water leaves the street, and everyone leaves the shelter. At this point, an earthquake begins. Roads crack, houses collapse. There are earthquakes in the street. Tectonic plates are moving across the planet. Imagine two magnetic spheres approaching each other. One ball is the moon, and the other is the center of the Earth. What do you think will happen to the center one? It's hundreds of thousands of kilometers from the Earth's crust. Now, everything is moving. Destructive cracks are appearing all over the world. The highest mountains are crumbling and turning into piles of rock. Seabeds are cracking and releasing magma from deep underground. Volcanoes erupt and spew magma. Clouds of volcanic ash cover both the sun and the moon. But the worst is yet to come. Conflict is inevitable. The moon flies over the planet like a ball in a round glass with a hole in the center. This force is driving the clouds over the planet. It's rumbling now, but in 5 minutes it will snow. Then night falls and it starts to rain. The water droplets are made up of clay and volcanic ash. People find it difficult to breathe without a gas mask. The atmospheric pressure is constantly changing. Some people experience severe migraine, and some people suffer from joint pains. But this is not the time to think about health. Humanity must figure out how to survive this conflict. When the moon collides with the Earth, a new gravity model will be created. The continents will change shape. They will merge into one giant landmass, or split into hundreds of smaller ones. The energy of the collision could burn up all the oxygen in the atmosphere and make the planet uninhabitable. There is no point in hiding underground because of deep earthquakes. People prefer to spend their last hours with their near and dear ones. The moon is getting closer. It is now in range of the International Space Station. The moon is covering the sky. Many cities are in shadow because of the tide. The tsunami hit the Earth at a height of several kilometers. Millions of tons of magma collide with the ocean. Billions of liters of water evaporate. Moisture rises into the air, mixes with ash, and floods the Earth from giant cumulus clouds. You thought about the complete destruction of the planet, but something strange is happening to the moon. You see giant cracks forming on it. The moon slowly begins to split into two parts. Both parts split into hundreds of large pieces. This stands out. The Earth has no natural satellites, just a pile of giant space rocks. But why is this happening? There is a space around our planet called the Roche limit. At this point, the Earth's gravity is stronger than the moon's. This means that the forces holding the moon together are weaker than the forces that are pulling it apart. People rejoice. Roche's boundaries have saved the planet. The moon will not enter us. It broke apart into millions of fragments and formed a ring around the world. Now, the Earth looks like Saturn. We are surrounded by a belt of moon rocks, large chunks destroying everything in their path. All the space debris. Satellites don't work, deprived of human communications and navigation. Humans will have to use paper maps again. Before these events, the moon held our planet's orbit at a certain angle. The axis is now rotated differently. One hemisphere will be closer to the sun, and the other will be in shadow. The north poles of the Arctic may become hot deserts, and the planet's equator may become covered with ice. Winter and summer will last for years. Lunar debris flies around Earth, but some of it lands on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the great destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world. In the vastness of space, among the countless stars that sparkle in the night sky, celestial events of unimaginable scale and power are taking place. Events that span entire galaxies and reverberate throughout the universe. Today we are witnessing one such event, a stellar cataclysm called a supernova. From ancient civilizations who took these events as omens, to modern astronomers who study them to understand the universe. Supernova have always fascinated us. The star Betelgeuse recently experienced a sharp decline, leading some scientists to speculate that it may soon become a supernova. If it does, it will be the brightest supernova observed from Earth in the last 400 years. Today, we're going on a journey. It's a journey to understand interstellar cataclysms, their impact on our planet, and the history of our place in the cosmos. We're delving into the fascinating world of supernovae. Stars are the protagonists of a vast cosmic theater. They are born, they live, and they die. But some stars in their final act are so spectacular that they outshine the rest of the galaxy. A supernova is the catastrophic death of a star. But what is a supernova? Simply put, a supernova is a powerful and bright stellar explosion. It occurs in the final stages of a star's life, when nuclear fusion can no longer sustain the outer layers of the star. As a result, the nucleus collapses under its own gravity, resulting in a powerful explosion that can engulf the entire galaxy in a short time. The energy released by a supernova is so great that it is equivalent to the energy released by our Sun over 10 billion years. Supernovae are not an exciting cosmic phenomenon. They play an important role in shaping the universe. They are responsible for spreading through space the elements necessary for the formation of planets and life. Most elements heavier than iron, including gold and platinum, are believed to have formed from supernova explosions. So, the gold in your jewelry, the iron in your blood, and the calcium in your bones were once part of a star that ended in a spectacular explosion. Before telescopes, space probes, and modern astronomy, ancient civilizations observed the stars. They saw patterns, created constellations, and recorded celestial events. Among these events was the sudden appearance of new stars that we now know as supernovae. One of the first observations of a supernova was made by Chinese astronomers in 185 AD. They described an invited star that appeared in the sky, was visible during the day for several weeks, and disappeared after 8 months. We now know it was a supernova, and its remnant, called RCW86, can be seen in modern telescopes. Another famous historical supernova is SN 1054, the Crab Nebula. It was discovered in 1054 by Chinese and Arab astronomers. This guest star was 4 times brighter than Venus and was visible during the day for 23 days. The remnants of this supernova we now call the Crab Nebula. The observations of ancient supernova greatly influenced these civilizations' understanding of the cosmos. They resisted the idea of an unchanging universe prevalent in many cultures. They are also used for astrological predictions and are often seen as omens. Today we continue to study supernovae, but this is an opportunity to learn more about the life cycle of stars, the formation of elements, and the history of the universe. Although our understanding of the cosmos is expanding, these stellar explosions continue to fascinate us with their power and mystery. Recently, astronomers have turned their attention to the star Betelgeuse and the constellation Orion. Betelgeuse, a red supergiant, is nearing the end of its life. It began to decline sharply in late 2019, leading some to speculate that it might soon go supernova. But then it returned to its normal brightness. The most common explanation for this event is that the star ejected a large dust cloud that blocked some of its light, shutting it out from our viewpoint on Earth. After the dust cloud dissipated, Betelgeuse's brightness returned to normal. This reminds us that the universe is not a static place, but a place where stars are born, live, and die. Every star in the night sky has a story that began before it even saw the light of day. The life cycle of a star is a journey of change. Betelgeuse has evolved from a mere cloud of gas and dust into a beacon of light that can span the galaxy. The journey begins in the nebula, a vast cloud of gas and dust. Inside these cosmic hotbeds, clusters of gas and dust begin to collapse under their own gravity. When a star collapses, it heats up and forms a protostar. As the nebula grows, the pressure and temperature increase. When the core temperature reaches about 27 million degrees, nuclear fusion begins. Now, a protostar is a main sequence star similar to our Sun. The star can stay on the main sequence, burning hydrogen for billions of years. But eventually, the hydrogen fuel runs out. What happens next depends on the mass of the star. In stars the size of our Sun, the core shrinks and heats up, causing the outer layer to expand. The star becomes a red giant. Eventually, the core collapses, and the outer layers are ejected, forming the planet's mantle. The white owl remains, but as we travel through space, we discover that not all stars have the same fate. A star can also go supernova. Its type is largely determined by the mass and composition of the original star, but it also has its own unique properties. For example, Type 1 supernovae have no hydrogen lines in their spectral analysis. The best-known type, Type Ymae, occurs in double-star systems. The Milky Way, the dense remnant of our Sun-like star, requires material from its companion star. When the white worm reaches a critical mass, it undergoes a thermodynamic explosion, resulting in a supernova. On the other hand, IB and IC supernova result from the collapse of massive stellar nuclei that have lost their outer layers of hydrogen, and the IC type for helium. Now let's look at the most common type of supernova we observe, Type 2. These supernovae come from stars much larger than the Sun. Stars 8 times more massive than the Sun can undergo such drastic changes. Throughout their lives, these massive stars are in a constant struggle between the internal gravitational force and the outward-pushing force of nuclear fusion. When the star runs out of nuclear fuel, gravity wins the battle. The core of the star is destroyed by its immense gravity. The collapse of the core is incredibly fast, occurring in just a fraction of a second and resulting in a massive explosion, a supernova. The outer layers of the star explode spectacularly, briefly engulfing the entire galaxy. The stellar debris may form a dense neutron star, or, if there is enough mass, a black hole. But the star's legacy lives on. The explosion spreads the cosmic elements formed during the star's lifetime, showering the cosmos with new stars, planets, and even the building blocks for life. When a star goes supernova, it's not just a light show. It's one of the most energetic events in the universe. The amount of energy released in a supernova explosion is so great that it's equivalent to the energy released by the Sun over 10 billion years. But where does this energy go? Most of it is carried away by neutrinos. These tiny, almost massless particles are produced in abundance during supernova outbursts. They travel at nearly the speed of light, carrying 99% of the explosive energy with them. The remaining energy is emitted as light and other forms of electromagnetic radiation. These include gamma rays, the most energetic form of light, and X-rays, which are less energetic but much more powerful than the light we see. The visible light of a supernova is so bright that it can cover an entire galaxy in a short period of time. This light can be observed at great distances, creating cosmic beacons for astronomers. Although supernovae are interesting to watch, they can be potentially dangerous. The enormous amount of energy and radiation released when a supernova explodes can have far-reaching effects, especially if the supernova is close to Earth. One major cause for concern is the impact on our planet's ozone layer. The ozone layer acts like sunscreen, protecting life from the sun's harmful ultraviolet rays. But a gamma ray burst from a nearby supernova can destroy the ozone layer, allowing UV rays to reach the Earth's surface. Increased UV radiation can have a detrimental effect on the Earth's biosphere. It can cause an increase in skin cancer in humans and other animals, as well as disrupt photosynthesis in plants and affect the entire ecosystem. In addition to gamma rays, the supernova emits a stream of high-energy cosmic rays. These particles could further damage the ozone layer and also create a stream of secondary particles in the Earth's atmosphere, which would increase the radiation dose. There is another interesting aspect of studying the dangers from supernovae: gravitational waves. These are in the periodic fabric caused by the most turbulent and energetic processes in the universe. Albert Einstein predicted the existence of gravitational waves in his general theory of relativity in 1916. Einstein's math showed that highly accelerating objects, such as neutron stars or orbiting black holes, could cause cosmic waves to break away from their source. And supernovae, with their incredible mass and explosive energy, are prime candidates for creating such waves. When a massive star collapses and explodes, the asymmetry of the explosion can create gravitational waves that propagate through space. By the time they reach us, these waves will be incredibly weak and pose no threat to Earth. But they do give us a new way to study the universe. Scientists have begun detecting these waves with incredibly sensitive instruments, opening up a new field of gravitational wave astronomy. Fortunately, the likelihood of a supernova explosion big enough to hit Earth is very small, but it's important to understand these potential risks. It reminds us of our connection to the cosmos and how events a few light years away can have repercussions here on our planet. As we have seen, supernova explosions are powerful events that can have far-reaching consequences. But did you realize that supernovae have played a role in shaping Earth's history? Scientists have found evidence of past supernovae in the form of iron-60 radioactive isotopes of iron in ancient geologic layers and Antarctic ice cores. Iron-60 does not occur naturally on Earth, but is created by supernovae. Our planet is believed to be strewn with the debris from these interstellar explosions. One of the most notable events was a Pleistocene supernova that exploded about 2.7 million years ago. Some scientists believe that this supernova may have affected Earth's climate during the Ice Age, perhaps even contributing to the cooling. There is also a theory that supernova may have something to do with mass extinctions. The idea is that cosmic rays from a nearby supernova could damage the ozone layer, which could increase ultraviolet radiation on Earth's surface and harm life, especially deep ocean organisms. These theories are still being studied and debated, and they show the impact of distant cosmic events on our planet. It reminds us that we are part of a dynamic and interconnected universe. When we look out into space, we are looking not only into the past, but also into the future. Stars will be born, live and die, and some will end their lives as supernovae. But what does the future hold for supernovae in our Milky Way galaxy? Astronomers estimate that a supernova explosion in the Milky Way occurs on average once every 50 years. However, most of these supernovae are not visible from Earth because dust and gas block the direct view. The last visible supernova in our galaxy was observed more than 400 years ago by the famous astronomer Johannes Kepler. But rest assured, astronomers are keeping a close eye on potential supernova candidates. These include stars like Betelgeuse in the constellation of Orion and in the constellation of Eta Keil. Both massive stars exhibit unusual behavior that astronomers predict may be approaching supernova on astronomical time scales. A recent study has shed new light on the mysterious behavior of the celestial giant Betelgeuse. This star, known for its semi-regular oscillations, has become the center of intense scientific attention. In the context of a star like Betelgeuse, these variations are noticeable in the brightness or intensity of light. The star does not follow a strict cycle of glowing and dimming, but has a predictable but not entirely regular cycle. Researchers have identified 4 distinct periods in Betelgeuse's evolution: 2000, 200, 420, 230, and 185 days. They hypothesize that these periods correspond to stellar pulsations, especially the radial fundamental mode and the first, second, and third oscillations. The pulsation analysis suggests that Betelgeuse is in the final stages of carbon burning in its core, given the complex interplay between pulsation and convection. The study also looks at the so-called Great Dimming event, which caused Betelgeuse's brightness to drop significantly between December 2019 and February 2020. Researchers during this period, Betelgeuse's effective temperature drops by about 100 Kelvin, which can lead to a large stellar mass ejection. This event has triggered observations and analysis aimed at unraveling the mysteries of this distant star. The researchers' results lead to an interesting conclusion. Betelgeuse could be the next star in the galaxy to go supernova. Given its current late combustion phase of carbon in its core, high luminosity and complex changes, Betelgeuse is a prime candidate for this exciting cosmic event. The study also notes that the star's high rotation rate as a red supergiant has sparked debate about its evolution, including the possibility of merging with a past star as a source of angular momentum. However, it should be noted that predicting when a star will appear is very difficult, as it depends on many factors that are not fully understood. Even if a star shows signs of becoming a supernova, it may take thousands or even millions of years before it becomes a supernova. But trust me, when it does, it will be a great show. Studying supernova is crucial to our understanding of the universe. These interstellar cataclysms are not just endings, but beginnings, filling the cosmos with new stars, planets, and perhaps the elements necessary for life. As we travel through space, we are constantly reminded of the majesty and mystery of the universe. Supernovae are evidence of the life cycle of stars, the formation of elements, and the interconnectedness of the cosmos. We have learned about their types, the dangers they pose, their impact on our history, and what the future holds. These celestial visions, as destructive as they are creative. They saturate the universe with new stars, planets, and perhaps the elements necessary for life. Studying supernovae is not only about understanding these amazing events, but also about our place in the universe. They remind us that we are made up of stellar material and are part of this vast, dynamic, and ever-expanding universe.